Hi, I'm Daz, and on the bench today is something a bit different. It's an ICOM IC7000 or R7000 receiver. I've actually had the pleasure of having a 700 and a 71 on my bench actually recently, just to check over. It's all to do with a SK sale, but nevertheless, I found it's a bit deaf on one of the bands, and some very strange things happening on the 2 meter band. Basically what's happening is the effect of the attenuator is reversed effectively on this band, so you get a better signal with it pushed in. And the band 25 to 90 megs, which is one of the bandpass filter, needs 50 microvolts to get it to work. But interestingly, the 512 to 1000 meg band is working normally. The only thing that's ringing a bell here is this band is basically switched by a pair of relays, but everything else here I believe is done by diodes. My initial thoughts is I wonder if there's a blown diode, and that's affecting the attenuator as well. So that's where my thoughts are at the moment. So I've come back to the ICOM this morning and find that the high band 512 to 1000 is gone deaf, whereas yesterday it was working perfectly. Very interesting. Anyway, I can get rid of the reflection. Basically, you've got a set of 4 bandpass filters. This last one is done by relays, these ones by the pin diodes. There's also a control, because these have got VHF diodes in to tune them as you go. So now wondering if something's wrong with the bandpass filtering. So here's the block diagram. You can see there's 3 bandpass filters here. The first 3 are switched by pin diodes, so they're biased on when this circuitry is powered and connect them into the RF. This bottom one is done by relays, and this one appears to be working fine. There's also pin diodes on the attenuator, and of course you've got the aerial coming in, and it does make you wonder whether we've had a lightning impulse and it's damaged those pin diodes. It's just a theory, so that might actually be where the problem lies. Just looking at the circuit diagram, each bandpass filter has actually got a dual gate FET in. This is the one that's working, done by the relays. This is the first one, which has definitely got a problem. You can see the pin diodes each side there, so when this circuitry is powered up, those pin diodes conduct and connect them into the circuit, whereas this bottom one's done by a relay. You can also see there's VHF diodes here. That's for your bandpass tuning, so as you tune along the band, presumably the microprocessor provides the voltage to keep this in tune, but I'm not particularly sure that's the problem here. I've got a feeling it might be these pin diodes, because this strange effect where the attenuator works backwards, but it's not like 20 dB, it's just a slight attenuation. It makes you wonder if one of these was stuck on, you'd get some sort of mismatch through the tuning circuits, and it would cause this peculiar behaviour that I'm seeing. They're located in this box, the bandpass filters, and you can see the adjustments here for this VHF diodes here, and there's the op amps. So I think this is where I'm going to be needing to look. Of course, just being diodes, you can soon tell if they're conducting. They'll have a volt drop of about 0.7 volts, so I guess that's where I want to be looking. Well, here's a close-up of the RF side, so that must be the attenuator switching relay. So you see strip lines on this, I guess they're strip lines. So you can see the VHFs, which must be these ones here, the yellow and orange marking. And of course you can see the tiny pin diodes as well. There's one at least. So just be a case of changing band and just checking some voltages, I guess. Right, so for instance I've got diode 5 here, so I've got 4.99 on that side and 4.1 on that side, so it looks like it's conducting, bit higher than 0.7, but it is on. The other one is here, and it's a bit of a bind to get at, but let's see if I can get at it. My dirty great head out the way. .9. Come on. 4.1. So very similar to the other side. So they appear to be conducting, and this section seems to be switched on. There was something I was wondering about, and that was the through pass, because I haven't managed to find L2 yet, but the voltage on L8, seemed a little bit low. It's only 500 millivolts, so I'm beginning to wonder where there's something wrong with the through pass. And there's a resistor on the other side here, so you'd expect there to be, yeah, that does not really look right, does it? It's not 0.7 there. Diode 2. Yeah. I'm on L1 here, and that should come 6 volts with the attenuator on, which it does. That's good. Now I've got L2, and that should be 6 volts when the attenuator is off, and it's 4.6 when the attenuator is on. So what's going on there? I think I ought to look at this first before I think of anything else. I'm looking at 700, I've got it on 700 meg, so this one would be in now, but it's interesting that this through pass voltage is still wrong. So I'm wondering whether it'd be a good idea to go through everything and check all the logic levels of what they should be. I believe it's driven from this IC here. That's what's providing the voltages, and there's some pull up and pull down resistors I can see. So it might be worth seeing what's switched on what band, and if the logic is all correct first before I go anywhere else. But yeah, I've just looked at this voltage on pin 7 of this IC, and it's not right on the through input either. So is this IC faulty, or is it something wrong the other end? These 820 ohm resistors seem to be showing that they're measuring, so I can see those. So have I got a shorted pin diode making voltages appear where they shouldn't be? So just looking at the circuit diagram, there's a BA618. This is an LED driver apparently. We've got an attenuation signal coming from the CPU going into pin 11, and we're getting it out of 6. Also there's a transistor here to invert that signal and put it back into this pin 10 here. This transistor's got a couple of resistors in it, so that's hence why the symbol looks as it does. Anyway, basically this is going 0.5, but this is not doing what it should do. It's basically inverting, which it shouldn't be. So I'm wondering if there's something wrong with this IC. There's an internal failure of the circuitry, or there's something going on all the way it's connected, so what it goes off to, there's something wrong with the pin circuit, so pin diode circuit. There's got to be one or the other, but this can shove out 500 milliamps, so I think it's unlikely whatever that's the pin diode circuit it's connected to is the cause of the problem. So this is the input to the IC. So when the attenuator's out we get 5 volts in. When it's off it's near 0. And then looking at the output pin, the attenuator's out and that should now be 6 volts, but it's 545 millivolts. When the attenuator is in I'm getting 4.5, which is completely opposite to what it should be. just looking at this pin, this is the actual attenuator. So 4.9 in, and looking at the output pin, we get 6 volts. That's how the other pin of this IC should be operating, so I'm thinking it's this IC now. So I'm just looking at the IC here, just see sort of buffer symbols really, but what's more interesting, that's what's actually inside the IC. So input comes in and this transistor's switched on, so you get a positive output, but it's not happening for some reason, it's inverted. Right, what I've done is I've jumped an external 6 volt supply to L2, so now we've got 6 volts to the pin diodes. Let's have a look, 6 volts on that side, 5.3 that side, that was D1, now do D2, 6 volts, 5.3, so that's good. I'm on 700 megs and I've got neg 117, and you can hear the tone probably coming from the headphones, so that looks good. I'm going to go through the rest of the bands now and see if it works. 433.1, we've got a signal at neg 117, good. 144.1, again good signal, so that's second band pass filter being tested. Okay, I'm on 50.1 megs and it's deaf still. So there's something wrong with this band 1 band pass. So I'm on neg 87, so obviously a secondary fault with this. I'm on R14 and I'm just looking at the voltage coming to the varicaps for this first band filter. I'm on 89 megs, and as I go down you can see 65 megs, you can see it's going down. 45 megs, it's 25 megs, whoops, went too far. So yeah, we've got a moving voltage there for the tuning, so that's good. Diode 5, one of the pin diodes, 4.9, 4.1, yeah, so something's happening there. Well, diode 11 is going to be fun, so what we got, I'll try and get it here, 4.9, and I think I can get in there. Have a look at the other side of it, 4.1, so it's the same. So pin diodes on, and the varicaps are being supplied with voltage, so what next? This is the gate that should be biased at 2 volts. Nothing. The other side, there's the 2 volts, so no wonder we've got no gain. There is no voltage on this gate. Now, either that's capacitor 17 has gone short circuit, or resistor 18 has gone open, or the gate is completely short circuited. Okay. With the power off to the rig, 24 ohms from ground to that gate. So is it the capacitor, or is the gate of this FET blown up? This is the second band filter, which is obviously working, and I can see the voltage at the towards ground via the ground resistor. I guess that's source, probably got that wrong. That's 1.4. So I'll try the same thing with this one, as the circuits are almost identical, and see what I get. On this one you can see I've only got 676 millivolts, so presumably that should be about 2 as well. As the resistors are identical, 47k bypassed, so FET isn't on. So this is the supply voltage to this bandpass filter. Goes through a 220 ohm resistor to the FET, and it's 4.8, so there's current flowing, yet there's no voltage at either gate. So if there's no voltage at either gate, I would assume this dual gate MOSFET is knackered. So We need a new, whatever it is, 3SK 121. About as obsolete as, well, you can get, I guess. So just to recap on what we were looking at. So this voltage here should be 2 volts and it's sitting at 0. So it looks like we've got a blown gate. This one was sitting around 4 volts, so there is current flowing even though there's no gate voltage. There's no gate voltage here. Well, this inductor's to ground, that's it. You're not going to get any voltage there. And this was just sitting at a few hundred millivolts. So, oh dear. I was just looking at prices of these FETs. £24.95. Really? Right, so back to the R7000. Okay, I diagnosed I've got blown gas FET, and this driver chip's got one blown output that drives the through connection rather than the attenuator. So what was decided after finding out gas FETs are £25, this chip is about £10, it was decided to spend a bit more money and get a replacement board that was for sale. I noticed it's been sent in a plastic bag rather than an anti-static one, so I hope it hasn't done any damage, but I doubt it. So I guess the next step is just to have a look to see if it looks the same, which it does really. So we've got just a few RF connections. There's a connector here, there's one at the back of the board, there's this one here, and these RF connections to the local oscillator phase lock loop board. So I hope after spending money on this that this is functional and works. So it shouldn't be too hard, and the tracking's all done here, so in theory the tracking should stay more or less online, I hope. So that's what I'll do next, is I'll get this swapped out. Much room there to get that out, is there? Right. Now do I pull the one out of there or pull it out of here? Looks like it's going to have to come out of here. Yes. Oh, I see. That one's permanently fixed. Oh, that's a bit of difference. Yeah, there's a connector, not a connector on this one. The connector's on the other end. Ah, I see. Yes, so the connector is on this PCB. On this one, it's a solid connection. Oh, that's not so good. It's detachable to the aerial, so I wondered why this cable was here, so that explains why. So these are not exactly the same. Interesting. So this is the original, ouch, just hit my head on the lamp. This is the original board, B990C. Notice some mods. Quite a few, the looks of it. This one is a B990H, so this is several revisions down the road. Well, that's not the most cleverest things I've had to do, but I've been through all my junk and damned if I can find some sockets off an old circuit board to fit this, but looks like the PCB is working, the front end, so that's a good result. I expect the next thing is to align everything. Well, a gentle squeeze and just cut the tip off, and that's removed this. So I've just basically got to dress this the same as that, and this is, I think this is going to be hit and miss whether this will be long enough, but we'll see. Yeah, it looks like there's a metal part crimped around the cable there. Well, I thought it was a piece of metal around there, but it's just the way it's been soldered. I'm guessing this is PTFE silver wire, I suspect. Well, not my best job, but that's satisfactory. Just hope this cable reaches. Something just horrified me. I just looked down here and found a screw was sitting near this gas vet here. Now I suspect when this board was taken out, someone undid the screw and dropped the screw in here and I didn't check, so I'm lucky from what I can see that nothing got blown up, but that screw was left in there and it was very near to that gas vet, so that is something to watch out for. Well, I've done another band test now. We've got the wire properly soldered in instead of my lash up with the two plugs. Now I can't find my 1 kHz notch filter. I know I've got one, so I'm just doing it by ear, but it says sensitivity should be -113 for 12 synad. Well, I can hear a tone at neg 117 throughout, so to better or worse effect, I think there might be some errors in the tracking on the bandpass, or I'm just being too fussy. So I think the sensitivity isn't too far out, but the next step will be, I guess, we'll be wading through the setup procedures, and they look quite well documented actually. They say what equipment you required, they show the location of the components, so that isn't so bad, but it's just time consuming setting everything up and doing the adjustments, I guess. There is a lot here, but then this is a complicated receiver. Good grief, more of it. I do sense it's off frequency on the higher ranges as well. It's all quite explanatory. Yep, that'll keep me busy for a while, won't it? First thing will be to get this screening can off the side. Loosen these back screws a bit. Just to, is it going to come out? Or is it caught in the... Well, that's fell on the floor. Must be a way to do this. Oh, there we go. Oh, right, very simple. Just slides. There we go. Well, this is the phase lock loop, and there's a lot of screening. Wow. You asked yourself if taking the lids off actually adjusts the setting, but maybe that's been taken into account for in the adjustments. Yeah, it's a case of pulling these all off carefully. There's tape as well. So I've taken off the cans that I appear to need to be able to get to. They have little pips that go in the holes, so I was trying to use this tool to try and lift that so they'll pop out, but it was quite difficult. There's a lot of adjustments here for a phase lock loop, but then it's a very complex radio. Well, here we go. This is the first test. Check it's more than 100 millivolts peak to peak on the scope on R139, so if not, adjust L29 and 30, which are here. So I guess this is how we'll do it. We'll just work through it, and when it's done, it's done. Had this Rackhole RF millivolt meter for years. Now I could use a spectrum analyzer, but I thought I'd use this. So I've just put a terminator on my device, my signal generator, and it's saying, oh, about -1, -2. That's not too far out. I'm on 0 dBm and I've got a terminator on there, so I'd say it's not far out. The lead's a bit long, so I guess the reason we're using spectrum analyzer is to look at the multiplier output. see something not exactly clean here because I'm getting changing readings, but this Racal stuff was really well made. It just seems to go on and on. I've got a deviation meter made by them and that seemed very reliable also. I've done nothing to it, so they must have been pretty well made. Okay, I gave in. I used the spectrum analyzer in the finish because the test of the second local oscillator output level, it doesn't change a lot when you trim things, so a little bit more resolution from the spectrum analyzer helped in that way. And of course I've got a spare plug that came off the spare board in order to plug it into the spectrum analyzer, so that was handy. Just continuing the adjustment of the frequency, these two trimmers are for the first local oscillator output, and I've given them a good twig either way to make sure I clean them. This one's not too far out. The second local oscillator, this one was quite a bit out, about 2 kilohertz, so it's worth adjusting that one. So I'm just looking at the diagram here for the 1 gigahertz mixer, which gives it the range above 1 gigahertz, and of course there's inductors here to adjust capacitors, but looking at this unit, it's completely different. So it says locate C1, it appears to be here. This looks like some sort of filter, an L2 for frequency adjustments in there. So yeah, this board is a rather different in the multiplier and mixer for 1 gig. However, a lot of the inductors appear to have the same number, L8, L2, etc. So these multiplier adjusters look a little bit different to me. So looking carefully here, this is the input preamplifier for above 1 gig. It's also a high pass filter, I guess. Here's the multiplier. So far I've failed to locate a point called W1, but I'm assuming C1 is somewhere in here. But then if you've got the lid off and you've got these lines, it's going to affect the inductance, so slightly puzzled how to proceed at the moment with this one. I found the output coupling line here, and that's what I'm using to set the frequency. I'm going to use to set the frequency. Whether I do the multiplier, I don't know yet. I'll have to think about that. But I'm on the this little output coupling line, which must go to the mixer. This being the mixer here. Next step is doing the tracking, so it's mostly voltmeter stuff, the looks of it. So just checking the voltages at various different points. So after a break of over 6 months, I'm back on the ICOM R7000. Looks like I've got to connect to this IC3 mixer now. Connect a voltmeter, so that's my next task. I'm quite surprised how much adjustment and things are out. It must be because I've changed this front end, but I'm just doing L46 and 47 at the moment. It's just a case of using the signal meter on the front panel and peaking it. So this is what I've just done. These RF traps are very difficult. I couldn't get that better than S7, but then I've discovered the meter reading high later on in the tests. But adjusting the meter wasn't too bad. The presets were where you expect them, even though that this has got a different board to the manual. So next page. Meter again. Interestingly, I couldn't get up to plus 60 on FM wide for some reason. Meter wouldn't quite go up even with the preset fully round, so that's interesting. It was reading 50 and up to about 52, but Interesting. So this looks like the last full page, thankfully. In order to get the squelch to work the meter correctly, I ended up having to repeat the S meter adjustment. Oh well. This one's fun, centering the meter. There's a position where the meter is centered when you're on the middle of an FM transmission, and then it shows an error each side, a bit like you find on an FM tuner sometimes. First problem I've got is there's no R127 in this, so what I'm discovering is the meter's a bit off centre, or quite a lot off centre on FM wide. So it should be here and it isn't there. Now I'm thinking, and I don't know if I've got this right, there is a small preset here next to the crystal for the FM detector, and that is not shown on my diagram, so I'm wondering, it's shown as a fixed device. When I put a metal object on one side to shift the frequency, the centre moves, so I'm wondering if you centre the meter using C14, so that you get a centimetre reading, so that the discriminator is dead on. I guess it's a quadrature detector type thing, so that might be what I end up having to do. So looking at this wide FM problem, I was able to centre the meter by adjusting the crystal, well, it's a ceramic resonator on the FM discriminator, but I can't help thinking that listening to FM radio there's a slight frequency offset, so perhaps I'll look at that later. But on narrowband it's fine, so I'm not going to worry too much about it. That was slightly out of bent, I don't know, this was slightly out of phase, centre stop. I'm now going to do the noise blanker. I remembered I do actually have noise generator, so I'll do that next. So noise blanker on, noise source off, noise source on. I'm not really sure if this is the right source of noise that I need, really. I realised when I just editing this video up that I didn't actually show you any numbers that I had when I did the adjustments. Well, not many of them anyway, so I'm just going to flick through. What I think I did is I wrote down what actually the reading was before I twigged it. So this will give you a little idea of what's out and what isn't. So if you're twigging one of your own, maybe it would help you out, but obviously the RF section is going to be completely different. You can see that was a long way out, so I just hope this little extra bit is some help to somebody who's perhaps working on one of these radios. I must admit it was the most complicated thing I've ever worked on radio wise. And I can't say for certain that I got it 100% right, but I think I got it pretty good. It certainly beats working on a 6 transistor super het, doesn't it? And I think that's where I possibly came in on the latter part of the video. Anyway, this is the 31st of December, so I'm just finishing the video just before New Year's Day of 2024. 400.1 400 megahertz to 0 calibration. Go and on. Right, so just going through some of the other tests now. I've already talked about the meter, the centering, centre stop I've done. The noise blanker I found easy to use the RMS meter actually to get the peak. The AF gain, the output was obviously a bit low into 8 ohms. And this last one was just getting a minimum at 5 kilohertz, so I had to modulate one of my signal generators externally to do that, and that's all of them. So I've done the -20 test again, and yes, this is the post adjustment on the right. That's before I adjusted it. Where I think I'm seeing the improvement is it's a lot better in the VHF section here. There's definitely an improvement. So there's a lot of work, but it's obviously paid off because we've got better sensitivity in most areas, with the exception of 500 megs. It isn't easy doing a measurement with mobile phones taking up all this band, so I've had to move frequencies occasionally, but I would say yeah, there's definitely a more even response apart from that 500 meg one, but hey ho, that's either going to be 3View or mobile phones depending on what the ITU say. So yeah, it was obviously worth doing the adjustments. We've got a bit more sensitivity for certain, but it's a lot of work. A lot of work going through all the tests on this radio. I think it's got to be the most complicated radio I've ever worked on. I've built an Elecraft K2, but this is so much more complicated, I've got to admit. So hopefully just fix the bulb in the meter, and I'll have to work out what that is. On the lamp front, unfortunately I wasn't able to get the technical spec for it, but I'm going to use a 12 volt 60 milliamp lamp and a 39 ohm resistor in series just to drop it to just under 12 volts, and that should be bright enough. I hope this heat shrink shrinks enough, but there we go. Right. Yeah, I think that'll do.
-0, dew point, -1, QMH1009. This is London North Information Broadcast.
Alright, okay, well I'll keep you to it because we're about to have tea really. Go on, just give him a shout, he's through to Barry. Barry, copy Nigel at Barry.